I'm Gerard Coutts, Managing Director of Gerard Coutts Associates. We call it GCA, a Victorian-based project management firm with projects across Australia.
Hi, my name's Patrick Munsey, one of the partners of Aivia Group, a New South Wales-based professional services and consultancy firm that offers the capture, processing and analysis of remote sensing data, primarily derived from drones. We specialise in photogrammetric 3D modelling and reality capture for use in aerial mapping and asset inspection.
Today we'll share a bit of a journey of how visually rich and interoperable geospatial data has been a vital tool for overcoming complex and time-consuming and in turn costly tasks in urban design and development projects.
We'll also talk about some of our experimentations with merging web mapping with real-time rendering for game-like experiences of geospatial datasets remotely.
During the peak of border lockdowns and state closures, we were faced with the challenge of managing the development of a 50-hectare project in Victoria. And this was all during the uncertainties of COVID. The development will combine renewable energy, recreational assets, community infrastructure and affordable housing. It's actually a really unique combination of assets. Part of the project involves the visualisation of our urban and architectural design to be presented to local and state government agencies and key community stakeholders. We are committed to minimising this project's footprint, as with all projects that we do. But this has particularly been on an emphasis on community transparency and collaboration. Drone technology and the ability to make geospatial data more accessible to project stakeholders has been a key part of unravelling a very complex puzzle and to achieve a great project outcome and vision. Thankfully, having captured valuable RPAS-derived data, which was processed by Aivia just weeks before border closure, an insightful reality mesh and other associated data was also generated, and that's enabled us to continue to work on tasks remotely even during project lockdown. User experience and intuitive visualization of complex data is integral to how we communicate with our clients. We've been able to expand our offering to clients by overlaying BIM models or building information models, 3D designs onto high fidelity aerial maps, digital elevation models and reality meshes. A project like this commands a wide range of skills and professions throughout its life cycle, and the collaboration with appropriately certified commercial partners is integral to achieving really good project success. We've been able to provide this data to our subcontractors to make their work more effective in areas such as fire risk analysis, biodiversity studies and traffic analysis. Now our partners, project contractors, can access detailed site data remotely via a range of web mapping platforms. We've actually estimated that this has saved approximately 10 to 12 days, and that's just up till now, on site. And we've been already able to save tasks from being completed remotely. So by doing them virtually, it's been a great success. So based on our client response, RPAS derived data has revolutionised the visualisation and design products that we offer as land use planners, and has allowed us to tackle more complex opportunities while confidently developing a pipeline of short and long-term equivalent opportunities. Flooding and drainage is a real key complexity on some projects and one of the biggest potential blockers for development. So the elevation modelling and other data sets derived from RPAS mapping in conjunction with surrounding public data sets has been a valuable tool in addressing the due diligence associated with this issue.
You can see in the video here that supplementary to our standard workflows, we've been experimenting with bringing large photogrammetrically generated reality meshes into the open source Unreal Engine. This enables us to view site data from a compelling first third-person perspective, while simultaneously providing a human element within the scene that is important to architectural design and visualization experiences. Using the wide range of tools, including the new cesium ion integrations, we're able to create simulations and user experiences with real-world 3D content positioned on a 2-scale globe with a geospatially accurate sun. I'd also like to point out that all of the game visuals you see in this presentation are user-controlled and rendered in real time. Photogrammetry is no new concept, even in the gaming industry, and has been used for some time to generate highly detailed game assets. However, the scale of such assets are normally relatively small due to compute and other runtime limitations. Large-scale full-site reality meshes can be supplemented with smaller objects from digital asset libraries to increase visual fidelity of features within the scene unsuitable for replication by aerial photogrammetry, such as trees and dense vegetation, without having to increase the project budget for unnecessarily detailed capture plans or an additional equipment such as LiDAR. That is, if visual detail is the driving requirement. We found that photogrammetry data sets derived from aerial imagery experienced from a human perspective, such as first and third person view, are better experienced at GSDs below an absolute maximum of 1 centimeter, with a noticeable degradation in user experience above this. This is an important consideration that will inform the future planning and modeling of reality meshes to ensure that client expectations are met. Some of the practical applications of these capabilities include interactive visualization of shadows and solar glare within the context of a site's physical surroundings. Engineering and data-driven approaches still function as the foundation of performing the reporting of these analysis. However, real-time visualizations like this are a great tool for the interpretation of such heavy-to-digest data. A project like this has demonstrated that data interoperability is just as important as the quality and capability of any single product or tool. There are many tools and platforms that can accelerate the adoption of the capabilities we're demonstrating today. However, when utilized in silo or attempting to integrate with other established workflows, their limitations and associated technical debt become quite apparent. With this top of mind, Aivia will be focused on further developing and scaling our geospatial data management systems and web mapping capabilities in the future. Long timelines of such large projects can be a limitation for innovations that utilize new tools with short development iteration cycles. Achieving such deeply integrated technology at scale requires strong foundations years in advance. The project is just starting off, however, the experimentation we're working on now will form the foundation of such achievements throughout the entire life cycle of the project, from now at pre-construction, through construction progress monitoring, to site completion and maintenance. The open source application Terrier.js, developed by CSIRO's Data61, has been a great springboard for our own development and prototyping of merging web mapping, real-time rendering, and data analytics in the browser. You can see here that we've been able to play graphically intensive application packaged at over 10 gigabytes instantly in the browser. No downloads required. Jumping from a factual web mapping analysis of the dataset to an interactive artistic interpretation of the site at the click of a button. If the device can stream Netflix and has a browser, then these types of applications can run on it. This carries some significant implications in making high fidelity real-time game experiences and visualizations accessible to end users who don't have specialized computing hardware. There are still some practical limitations, however, such as latency on standard internet connections that can make using virtual reality headgear in this configuration too disorienting. However, local network configurations don't have this issue. The work completed at this stage of the project will act as a strong foundation for the potential development of a future digital twin with the integration of real-time data of the site's assets such as the solar precinct. I'm really excited for the next year with Pixel Streaming and Unreal Engine 5 moving to production and the ecosystem of GIS integrations maturing, which will allow us to dive even deeper into our exploration of merging our RPAS data, web mapping, and remote real-time visualizations. We'll also be looking into the automation and integration of IoT and metadata with these systems. I hope this presentation's been interesting and has given you some useful ideas of what is achievable with the awesome tech that we surround ourselves within the industry. Thanks.
Thank you very much, Gerard and Patrick, for me, what was such a great presentation to show about town planning, future land use, and obviously the use of these awesome tools from a data and AI and drone photogrammetry perspective. But what I really liked was, I think they're only on the journey to start planning a large precinct from the start like that. You can see what they were talking about was that embedment, of these tools right into execution, and then to the ongoing maintenance of the facility. And I think, this is, no matter what industry, what operation we're talking, I think we're just on the precipice, of this. At the moment, we're trying to retrofit tools to a brownfield site, no matter what site you're talking and what industry, and that's hard. Legacy issues, around obviously the site, but here what we're seeing is obviously it getting embedded in greenfields right from the start. And certainly we're seeing this in industries, oil and gas. My perspective from mining as well is that embedment of these tools as you start planning a greenfields build of even a new mine. It is somewhat, I wouldn't say it's a walk in the park, but it's definitely easier than brownfields. And then obviously that productivity saving, they spoke about already 10 days saving in going to site. That makes that whole team far more productive and adding value to this town planning, and they're only on the start of the journey. So really, really enjoyed the presentation.